Hi, in this video, we're going to do a program that you can see how queues work. And it's going to be a simulation of a printer lab. So, for example, let's think that you have a lab at your school that has 20 computers and one printer. And the people running the lab want to see how efficient it is. How long does it take students to be able to get their print job done because of backups or whatever? So I'm going to do a PowerPoint here that has this information in here, and then we'll get started on working with the. Well, I don't like the way that it does this on my computer, so we'll just do it this way here. So students send printing tasks to the shared printer. The tasks are placed in a queue to be processed in a first come, first served manner. Questions about this process: can the printer handle a certain amount of work? If not, students will be waiting too long. Consider the following situation. On an average day, about 10 students are working in the lab at any given hour. Students typically print up to twice during that time. Length of these tasks range from 1 to 20 pages. Printer can process 10 pages per minute in draft, 5 pages per minute in better quality. What page rate should be used? So to build a simulation that models the lab, we need to construct representations for students, printing tasks, and the printer. I don't have the figure on this, so you'll just have to go with this. As students submit printing tasks, we will add them to a waiting list, a queue of print tasks attached to the printer. When the printer completes a task, it will look at the queue for the next task. Our interest is the average amount of time students will wait. We need to use some probabilities. Students may print a paper from 1 to 20 pages. Simulate print task length by using random number between 1 and 20. If there are 10 students and each prints twice, there are 20 print tasks per hour on average. What is the chance that at any given second a print task is going to be created? Consider the ratio of tasks to time. 20 tasks per hour means that on average, there will be one task every 180 seconds. It's 20 tasks per 1 hour times 1 hour divided by 60 minutes times 1 minute divided by 60 seconds equals one task per 180 seconds. So for every second, we can simulate the chance that a print task occurs by generating a random number between 1 and 80. So if the number is 180, we say a task has been created. So here's the main simulation. Create a queue of print tasks. Each task will be given a timestamp upon arrival. For each second, which is the current second, does a new print task get created? If so, add it to the queue with the current second as the timestamp. If the printer is not busy and if a task is waiting, remove the next task from the print queue and assign it to the printer. Subtract the timestamp from the current second to compute the waiting time for that task. Append the waiting time for that task to a list for later processing. Based on the number of pages in the print task, figure out how much time will be required. The printer now does 1 second of printing if necessary, also subtracts 1 second from the time required for that task. If the task has been completed, the printer is no longer busy. After the simulation is complete, compute the average waiting time from the list of waiting times generated. So we're going to create classes for the three real-world objects: the printer, the task, and the print queue. Printer class will need to track whether it has a current task. If it does, then it is busy, and the amount of time needed can be computed from the number of pages in the task. The constructor will also allow the pages per minute setting to be initialized. The tick method that decrements the internal timer and sets the printer to idle if the task is completed. The task class will represent a single printing task. When created, a random number generator will provide a length from 1 to 20 pages. We'll also need to keep a timestamp to compute waiting time. Okay, so what we're going to do is we're going to go ahead and get this out of the way here and start creating this program. Okay, so let's start it, get a blank one up here. And like I said, what I'm going to do is copy the code over a little bit at a time and we'll go through it. So the first thing we're going to have to do here is the printer class. Okay, so I'm going to bring that whole thing over and then I'll go through it with you line by line. Okay, we need to import random so we can generate the random numbers, and from the queue we need to import queue. And we already created that in a previous video. So our initializer, our INIT, we're going to pass in the pages per minute. So page rate is going to be the ppm, the pages per minute. Our current task right now is none, and our time remaining equals 0. Our tick is if our self.current task does not equal none, then the time remaining is going to be minus equals 1. Okay. If the self, and then we're going to check to see if self time remaining is less than or equal to 0, then our self.current task equals none. We finished the task because we got down to 0 on that. Okay. Our busy is if the self.current task does not equal none, return true, else return false. So if the current task equals none, it's not busy. But if it equals something else, then it is busy. Okay. And then our start next is if our current task equals new task, which we haven't created yet. Okay, so that's going to come up in a different place. Self.time time remaining equals new task.getPages times 60 divided by self.page rate. Okay, so that's going to calculate that out for us there. Okay, so let's get the next section. This is going to be our task. Okay, so our task then is in our initializer, our INIT, we're going to pass in the time. So self.timestamp equals time. Self.pages equals random.randrange 1 through 21. So that's the number of pages they're going to print 1 through 20. Okay, timestamp is when it came in. That's what's going to be passed in. Okay, so we have our getStamp, which is to return self.timestamp. GetPages returns self.pages. And then wait time is we pass in the current time and return the current time minus the self.timestamp. That's how much the wait time is for this particular task. Okay. And then we've got our simulation. And most of the time when I create programs, I always use a main. But in this particular case, I'm going to use simulation instead of main because it makes more sense on the name of it. So on this, when we call the simulation, we're going to pass in the number of seconds and the pages per minute. Number of seconds is how long do we want this to run. Normally, if I would test this out, I would run it like for maybe 360. If we did that for seconds, then that would be 60 minutes, which may not be long enough. So maybe we do it for 3,600, which would be more like 6 hours. Okay. So the lab printer equals printer. So we create a printer, passing in the pages per minute. Okay, so I'm going to go back and forth on this. So here's the printer up here, passing in the pages per minute. So we're going to create an object of the printer class at that point. Our print queue is going to be equal to queue. Waiting times is going to be an empty list to start with. Then we're going to run through this. For current second equals range num seconds. So it's going to run through for the number of seconds that we supplied to it. If there is a new print task, then task equals task current second. Print queue equals end queue task. So if we have a new print task, we're going to pass that into or put that into our print queue. If not, lab printer dot busy. So if the printer is not busy and not print queue is empty, so we have a print job to do, and the lab printer is not busy. Then next task equals print queue dot dq. We're going to pull a task off our queue. Waiting times dot append, and we're going to pass in our next task dot wait time current second. Okay, so that's how much the waiting time was before it got picked up from or out of the queue. Then lab printer dot start next task, and then once we get done with the if statement, lab printer dot tick. That's to adjust for running through this our num seconds. That's how many to go to the next one on that. Okay. Once we get done, run through all the seconds on here. Then what we want to do this a couple times here. Our average rate is the sum of our waiting times, sum of all the values that were in our list, divided by the length of our list. And then we're just going to print out that information. Okay. I'm going to change this in here to an F. I'll do that right here in front of you here. So that'd be average wait. Change this here to curly brace, average wait, colon, 6.2F. And we do a curly brace right here, seconds. And then I'll take this stuff out here, because that would be our curly brace print queue dot size in the curly brace. And let me expand this out so we get the whole line on there. There we go. Tasks remaining. And then then I don't need any of this stuff here because I've already done that. So we can back this up to there. Okay. So hopefully I got all that typed in there right. So it's going to print average weight and then get the average weight variable, formatting it to 6.2 floating point there. Then a print out a space and SEC S for seconds, and then the print queue dot size, tasks remaining. Okay. So we still got to put in one more thing in here. Actually, two. I do have a main, so take that back. I'm going to go ahead and do this whole thing at one time here. So new print task is we get a rand range from 1 to 181. Remember we did that. So if that number that we get is at 180, that means that we have a print task. Otherwise, we don't. Okay, and so that was up here. Someplace. I know it's in here someplace. There it is, sorry. If new print task. So it's going to call that. If the number is 180, it will return true, and it will run through that if statement. Otherwise, it will return false and not do that part and come down here. Okay, so and then we have our main. In this case, we're gonna run this for 18,000 seconds. We're gonna run this whole thing 10 times. We're gonna do it for 5 pages. I'm gonna change that to 10 pages a minute. That's in draft mode, and then I'll put in. And then come over here and indent this there. Okay, so let's get this saved and we'll go ahead and run this and see how it works. Save it as printsimulator.py. Now for this to run, don't forget you have to have your cue in the same folder. Okay, so let's run this and see what happens here. And there we go. Okay, so at doing it as 10 pages per minute, these were the wait times, not very many, okay? And we had none left over when we got done with the whole thing. Okay, good thing. Okay, but what happens now if students are saying, wait a minute, I need to print mine out in good quality or the instructor won't take it. So we change that to our 5 pages per minute and run it. Okay. Now our times are a lot longer. Okay, 240 seconds is 6 minutes. So you can see some of these. No, I'm sorry, it's 4 minutes. 359, 360 is 6 minutes. Okay, so those are the wait times on getting that, and then these are the number of tasks that were still left in the queue after running it. So maybe they might want to think about getting 2 printers. Well, what happens if, let's see, you can modify all these numbers in here. Let's see, we did the pages per minute. I'll find another random number here that I'm looking for. What if students normally print out 5 to 40 pages? Okay. And I'm going to take this up to 10 first of all, to run it for the draft mode quality. Okay, it's about on the same level as this one up here. Look at this one here where it was 42. That would be 7 minutes, and there were still 6 in the task bar in there. But now they want to have good quality. And you'll see what happens when we do this. Look at the numbers now. Long wait times. I'll do this one here. You divide this by 60, so 6 into 37 goes 6 times. So this is waiting an hour. Okay, this is waiting a lot more than that. And then look at the number of tasks that are still in there. So that's the type of thing you want to look at. So now what you can think about is, well, what happens if we add a second printer? And we have one printer that does drafts, and we have one printer that does better quality. Okay, so now you have to do a random number between 1 and 2 on which one it is, and then have 2 different queues in there. So some things that you can do to modify the simulation to do some other things with it. So I hope you got some good information out of this, and this helps you out with queues. Bye.